Today's video will explain the strategy design pattern. Hello, I'm James Helfrich. There are three algorithm abstraction design patterns, the first of which is called the strategy. The strategy allows the client to choose between different variations of an algorithm. This video will define the strategy design pattern, explain how to build it, and also demonstrate how to integrate it into your application. Algorithm abstraction is the process of taking potentially complicated algorithms and reducing it to its components, allowing the components to be reused and reassembled to create new combinations. There are three types of algorithm abstraction design patterns: the strategy, the template method, and the decorator. Today, we're going to talk about the strategy. In this one, there are multiple variations of an algorithm which the client can choose from. The strategy design pattern consists of three parts: the client, the abstract strategy, and the concrete strategy. Now, the client is the part of the program that's actually going to use the strategy class. Our goal is to make things as simple and as easy as possible for the client. The abstract strategy is only going to represent the contract that the client interacts with. Usually the abstract strategy has no code and has no attributes. It simply provides an interface for the concrete strategies. Now, each individual concrete strategy represents an algorithm that is to be abstracted. There are several concrete strategies, one for each unique variation of the algorithm. So let's take a look at the class diagram to see how this works. We have the context, which is going to utilize the strategy design pattern, and it's going to have an instance of an abstract strategy. So therefore, I need to have an abstract strategy by composition. And then the abstract strategy is going to have a method called execute, and this is actually going to perform the action. Now it's going to take a context as a parameter so it can perform an action on something. Now we're going to have a concrete strategy one that's going to implement our abstract strategy, and it's going to have its own version of the execute method. And then we're going to have several other of these as well. Now the context will then perform some action, and this action will then utilize S, which is our abstract strategy, which will execute S.execute. And X.execute will execute one of the concrete strategies. So for an example, I want to have a program to chop vegetables. And there are several different ways I can chop vegetables. I can mince it, I can slice it, or I can crinkle cut it. Now, mince and crinkle cut happen to call other functions to do part of the work, but that's okay. So first of all, I'm going to take my mince collection of functions, and I'm going to put that into a class called mince, and chop we'll call mix and recombine. Now my slice will become its own class as well, and chop will just have the slice algorithm, and crinkle cut will have the chop method, but it'll also call the flip private method. Now, what's similar about all three of these concrete strategies? Well, they all have the same interface, and that's called chop. And they're all related by inheritance. Now, the client is called vegetables, and chop will have an instance of vegetable because it will pass it as a parameter, but vegetable will contain by composition one chop class. Now, here's another example. I have a collection of different types of bank accounts, and I need to handle fees. There's a fixed annual fee, a percentage of transaction fee, and there's a fixed fee per transaction. So what I'm going to do is I'm going to create a fixed annual, a transaction percent, and a transaction fixed concrete strategy. And these will have a compute fee method associated with them. Notice they're going to have different private member variables, and those attributes are going to refer to the amount of the annual fee, the percent of the transaction fee, and the amount of the fee per transaction. Now, what is the common interface between all these? Well, it's the compute fee method, and I will put this in the compute fee abstract class. And they're all related by inheritance. Now, my client is going to be an account, and notice how compute fee is going to reference account, and account is going to have one instance of compute fee by composition. This is example 43.1 in the strategy section of the algorithm abstraction chapter of the software design textbook.